For today, we have a new topic, but before that, let's have a recap about our previous discussion, which is all about Coulomb's law.
I have here an example. Two balloons with charges of 3.37 microcoulomb and negative 8.21 microcoulomb attract each other with a force of 0.626 Newton. Determine the separation distance between the two balloons. First things first, input the given, and for this problem, the unknown is the distance between the two balloons. That is the R. Now take note, the first charge is equal to 3.37 times 10 raised to the power of negative 6 coulomb. And the second charge is equal to negative 8.21 times 10 raised to the power of negative 6 coulomb. To solve the problem, of course, copy the formula and then substitute these given and leave as it is the unknown. To simplify this, to simplify the right side of the equation, multiply this to the numerator. So we have, and the next process would be the cross multiplication. Take note, the unknown should always on the left side of the equation. Therefore, 0.626 Newton times R squared is equal to 1 times the numerator. We have this one. Multiply 3.37 times 8.21. We have 27.67, so round off up to 2 decimal places. Combine the exponent, we have times 10 raised to the power of negative 12 coulomb squared. To isolate R squared, divide both sides by this value. Now, this time, let's simplify first the right side of the equation, specifically the units. We have here the coefficient, divide, and 1 over Newton, then Newton meter squared over Coulomb squared. Coulomb squared, we have here. Then copy this one. 1 times Newton meter squared times Coulomb squared is the numerator, and Newton times Coulomb squared is NC2. Cancel out, and then cancel out also the units that is common. And get the quotient. By the way, this one is just simply the decimal form of this scientific notation. We have here negative 3, so therefore from the decimal point, we are going to the left 3 times, or jump 3 times. That becomes 1, 2, 3, 0.24903. Get the quotient, that's 3.98. What's left is meter squared. Now, to get the final answer is just simply get the square root of this equation. And our final answer would be R is equal to 1.9 meters.
Now, let's start our next topic by answering this question. How does an object get charged from neutral to charged object? Charged object is created when electrons are transferred to or removed from an object. Because electrons have a negative charge, when they are added to an object, it becomes negatively charged. When electrons are removed from an object, it becomes positively charged. Any energy from any source, atoms donate or gain electrons, and that makes them charged. Another question, how this transfer of electrons being done? And that would be our lesson for today. Methods of charging. These are charging by conduction, charging by friction, and charging by induction. Charging by conduction or charging conductors by contact. In electrical sense, conduction allows the flow of electrons between objects through either touching two things together or attaching a wire between them. So to charge by conduction, we start with one charged object and we use it to charge another object or a neutral object. We have here an illustration. The first object is a metal sphere in neutral state, having equal number of protons and electrons with insulated stand. The second object is the ebonite rod, having a negative charge. When this negatively charged rod touches the sphere, the electrons of this rod will react, causing them to find another stable environment. When that happens, the metal sphere will receive an electrons. In that case, from neutral, the metal sphere now becomes negatively charged. We have here another example. Still, we have a neutral metal sphere with insulated stand. And this time, we have a glass rod as our second object having a positive charge. Now, when this positively charged rod touches our neutral metal sphere, kay daghan man og number of protons si metal rod, iyang i-attract ang electrons nga naa sa metal sphere. When that happens, metal sphere loses electrons. Therefore, from neutral, the metal sphere now becomes positively charged because nihatag man siya og electrons. Take note, when charging by conduction, the object becomes the same charge as whatever touch it. In our dialect, kopyahon sa neutral object kung unsa man ang charge sa object nga ni-touch niya. The second method is charging insulators by friction. As you can see, we have two illustrations. On the first illustration, we have rubber and fur. Fur is the soft hair of some animals. And on the second illustration, we have the glass and silk. When insulators are rubbed together, one gives up electrons to become positively charged, while other accepts the electrons and becomes negatively charged. Now, question. What's the reason or what's the basis in this method why an object loses or gains electrons and not the other one? Why is that the rubber or the silk loses electrons and not the fur or the silk? To answer that question, let's understand this term, triboelectric series. It is a list of common materials that were experimented on and found to behave in a predictable way. And these are ranked materials according to their tendency to gain or lose electrons. Okay, let's understand these ranked materials using our dialect para masabtan. Now, these materials nga duol sa positive, kaning positive ug negative, mura siyang pattern gigamit sa triboelectric series para mas masabtan. If duol gani ang materials sa positive, that means they will tend to lose an electrons. Kay mo lose man sila og electrons, if i-combine sila or if i-rub sila to lower in rank nga materials, they will become positively charged. Anong positively charged? Kay sila man ang giver of electrons or sila ang mulus. And these materials nga duol sa negative, if i-rub nato sa mga materials nga duol sa positive, they become negatively charged. Kay sila man ang receiver sa electrons. Another thing, The farther away two materials from each other on this series, the greater the charge transferred. And the materials next to each other on this series might not become charged at all when they are brought in contact with one another. And lastly, materials in the middle of this list, steel and wood, for example, are items that do not have a strong tendency to give up or accept electrons. We are down to the last method, charging by induction. This method is a two-step process. First is a neutral object becomes polarized. Second, the neutral object is grounded. Again, grounded, causing the object to become charged. Example using a negative rod and a neutral sphere. In this method, kay duha ka object gitapad close to each other but not in contact. If we put this negatively charged rod closer to the sphere, the neutral sphere becomes polarized. When we say polarized, as you can see, naaray nag-redistribute ra ang protons ug electrons sa sphere. The protons kay ni move closer to the rod, while the electrons kay ni repel wherein ni move sila to the other side of the sphere. If we pull the rod, the atoms or the subatomic particles kay ni move sad sila back to their original places. Therefore, the sphere is no charge yet because wala man siya ni lose or ni gain og electrons. Now, how to make this sphere a charged object? We have to do something else in order to make the sphere charged. To solve this problem, we're gonna use the technique called grounding. Now, we're gonna keep this negatively charged rod near the sphere. That's the induction part. And then we are going to place a ground on the sphere. A ground can be a wire that is connected to some other metal placed underneath the soil or any place. And this ground is a very large conductor. Earth is one of the best conductor, even us. Now, once we placed a ground on the sphere, this time, those electrons that wanted to get away from the negatively charged rod can now have somewhere else to go. They don't have to go to the other side of the sphere. They can make their way through the ground. And if they make their way to the ground, that means the sphere is losing an electrons. In that case, the sphere have now a surplus protons, so it's gonna be a positively charged. Now, if we are going to pull the rod, we still have a positive charge sphere. Therefore, the once neutral object becomes the opposite charge of the charged object that polarized it. Let's talk more about grounding. We have here two illustrations, and these examples shows how a charged object change into a neutral one. Let's start with the first illustration. We have here a positively charged sphere. This positively charged object pulls electrons from the earth through the ground to become neutral. And on the other hand, we have the negatively charged object, and this negatively charged object pushes its excess electrons to the earth through the ground to become neutral. And that ends our discussion for today's topic.